Pre-statistics. Exponential functions, part 4. Lesson objective. Use 2 points to find an equation of an exponential function. Example 12. Find the equation y equals a times b to the x power of the exponential curve at the right. So let's zoom in where we can see some more values. It looks like the y-intercept is 1. It's hard to tell. But if we look carefully for sure, we see when x is negative 1, y is 4. And the reason why it's 4 is because our scale here is 2. Here's 2, 4, 6, 8, 10. So we have 1 point. When x is negative 1, y is 4. The next one, when x is a negative 2, y is 16. So we have 2 points. When x is negative 1, y is 4. And when x is negative 2, y is 16. So we have our 2 points. Now we can answer this problem just like we did in the previous problem. We have 2 points, so we need 2 equations. The first equation will be 4 equals a times b to the negative 1 power. So this was our first point. X is negative 1, y is 4. And the second point, and the second equation, 16 equals a times b to the negative 2 power. X is negative 2, y is 16. So taking the largest y value, putting it on top, the second equation on the bottom, dividing the left-hand sides, the right-hand sides. We have 16 divided by 4, which is 4. The a's will cancel, and now we have b to the negative 2 power divided by b to the first power. Since b's are like terms, we subtract the exponents, and we have 4 equals b to the negative 1 power. Solving this equation, one way of doing this is to cross multiply. 4 times b equals 1 times 1. Dividing by 4, we see that b is 1/4. To find a, we substitute the value in for b. We pick a point. I'm using the first point. X is negative 1, y is 4. Using our properties of exponents, this becomes 1 to the negative 1 power, 4 to the negative 1 power. So the 1 will be sent to the denominator, the 4 will be sent to the numerator. So this becomes 4 over 1, and 4 over 1 is 4. We multiply that by a, we have 4a. So 4a equals 4. Dividing by 4, we see that a is equal to 1. So our equation is f of x equals 1/4 to the x power. It appeared on the graph that the y-intercept was 1, and now we know that's true. And it would have been easier to solve this problem if we knew the y-intercept was actually 1. Because in that case, we have our value of a. We only need one more point to find b, and negative 1/4 will work. And plugging in those values, we get 4 equals b to the negative 1 power, which means b is the 1/4. And we end up with the same equation. So if we can find the y-intercept from a graph, it makes the work a lot easier. To find the equation of the exponential function using the graphing calculator, again we go to Stat, enter for edit. We type in our x coordinates in list 1. So the first one was negative 1. The second x coordinate was negative 2. Scoot over to list 2 and put our y coordinates, 4 for the first one, 16 for the second. Now we go to Stat, Calculate, and 0 for exponential regression. Hit enter. I'm not going to store it
and L1 this time. I'm just going to calculate it. Hit enter. And here we see A is 1 and B is 0.25, which is the same thing as 1/4. So we can do it algebraically, or we can use technology. So let's summarize exponential functions.
Algebraically, numerically, and graphically. Algebraically, it's written in this form: f of x equals a times b to the x power. A is our y-intercept, b is our base, and if b is between 0 and 1, it'll be a decreasing function. If a is positive, a is negative, it'll be an increasing function. If b is bigger than 1, it's an increasing function. If a is positive, if a is negative, it's a decreasing function. But the base b cannot be negative. Numerically, as x increases by 1, the y values are multiplied by the base value. The value of a is the y-intercept. And graphically, exponential functions look like this or this. This is an example of an increasing exponential called a growth. And this is an example of a decreasing exponential, and this is called an exponential decay. Thanks for watching.